So I'm going to go over a little bit more examples from the section 1. So section 1, we introduced the concept of complex numbers, which represent negative values under a square root. So previously, if we saw a negative number under a square root, we said we can't simplify it, it's not a real number. But now we've introduced this concept of I, which represents the square root of negative 1. And we want to make sure we simplify all powers of I when we perform multiplication or division. So our final answer can never contain a power of I greater than 1. So anytime we see an I squared, I cubed, I to the 4th or higher, we always have to simplify it. So your final answer should only contain I, -1, -I, or 1 when it comes to powers of I. So first we're going to look at some examples where we're simplifying complex numbers with just seeing the negatives underneath the square root. So what we like to do is rewrite the problems so it's separated from the real number and the complex number. So when we see the square root of -81, we're going to break it down so it's the square root of 81 times the square root of -1. And now we can simplify the square root of 81 because it's a perfect square, so it simplifies as 9. And the square root of -1 we write as I. So 9i is fully simplified. Next, we have the square root of -156. So we're going to break it down the same way. The square root of 156 times the square root of -1. Now, 156 is not a perfect square, so we're going to break it down like we did in Module 3. So we break it down as 4 and 39. 4 breaks down as 2 and 2, and 39 can break down as 3 and 13. So previously we talked about the fact that you can only bring out a value if it is a group of 2. So there is a group of 2's. So we have 2, and then we put the I that represents the square root of -1. And then underneath the radical, the 3 and the 13 are going to multiply back together to give us 39. We can also simplify complex numbers when there are variables involved as well. So we break it down just like we did with the numbers. We do 28x squared y to the 7th times the square root of -1. And we simplify it like we did previously. So 28 we break down as 4 and 7, and 4 we can break down as 2 and 2. So there is a pair of 2's, so we'll have 2i, and then we're going to simplify our variables. So in x squared, there is one group of 2, so we'll have an x, and in y to the 7th, there are 3 groups of 2, so we'll have y cubed. And underneath the radical, we have 7. We had an even group of x's, so there aren't any x's left over, but there is one y. So our final answer is 2i xy cubed radical 7y. Typically when we're writing a simplified answer that involves variables, we will put the I with the number and not at the end. It is also acceptable to write it as 2xy cubed and then put the I and then the radical 7y. It's just typically you put the I with the number. Our last example is the square root of -100 x to the 5th y to the 10th z squared. So we're going to break it down like the previous examples. 100 x to the 5th y to the 10th z squared, and then times the -1. 10 is a perfect square. It breaks down, 100 is a perfect square, and it breaks down as 10 times 10. So we're going to have 10i. And then x to the 5th has 2 groups of 2, so we're going to have x squared. In y to the 10th, there are 5 groups of 2, so y to the 5th. And z squared is 1 group of 2, so we have just the z. And then underneath the radical, we didn't have a number left over since 100 was a perfect square. And then the only variable that didn't have an even group was the x. There is one left over. So our final answer is 10I x squared y to the 5th z radical x. Next, we're going to take a look at operations with complex numbers. We're going to look at addition, subtraction, multiplication, and division. So when we are adding or subtracting complex numbers, we do it very similar to when we were adding and subtracting polynomials. We combine like terms. So with 9 plus 4i plus 1 minus I, we can combine, our real numbers are like terms, so 9 plus 1, which is 10, and our complex numbers are like terms, so 4i plus negative I, which is a positive 3i. And 10 and 3i are not like terms, they don't combine, so that's our final answer. You can think of I as a variable, so when we combined x's, like 4x plus negative x was 3x, and we didn't change the exponents of the x's when we added or subtracted. It's the same thing with I. The exponents don't change when adding or subtracting. Okay. Our second example is subtraction. Now, similar to when we were subtracting polynomials, I told you to distribute the negative into the parentheses before combining like terms. We're going to do the same thing here with our complex numbers. So we're going to drop the parentheses around negative 7 minus 5i. Then we're going to distribute the negative to our second set of parentheses. It's going to become plus 3 minus 2i. Now we're going to combine like terms similar to the addition problem. So negative 7 plus 3 is negative 4, and negative 5i minus 2i is negative 7i. I think the most common error I see when people are subtracting complex numbers is forgetting to distribute that negative to the second term in the parentheses. Okay. Next, we're going to take a look at multiplication. So similar to when we multiplied polynomials, where we use the distributive property, we're going to do the same thing with complex numbers. Everything in the first set of parentheses is going to multiply to everything in the second set of parentheses. And the most common error with multiplying complex numbers comes from the simplifying the I squared term. A lot of people forget to change the sign when they simplify it. So our first two terms are 6 times 8, which is 48, and then 6 times negative I, which is negative 6i, 5i times 8, which is 40i, and then 5i times negative I, which is negative 5i squared. So we have to simplify the I squared. So from the notes, we know I squared is equal to negative 1. And that's because I is the square root of negative 1, and when we square it, anytime we square a square root, they cancel, so we're just left with whatever is underneath the radical, which in this case is a negative 1. So our problem becomes 48 minus 6i plus 40i minus 5 times negative 1. So now that negative 5 times negative 1 is going to become a positive 5. So we get 48 minus 6i plus 40i plus 5. Now it's an addition problem, and we're going to combine like terms. So 48 plus 5 gives us 53, and negative 6i plus 40i gives us 34i. So the last example we're going to take a look at is division. And similar to Module 3 when we're dividing polynomials, when we had radicals in the denominator, we're not allowed to divide by square roots. It's the same thing with complex numbers. We don't want to divide by I. So when we divided by radicals, we got rid of them by multiplying by the conjugate. And with complex numbers, we multiply by the complex conjugate. So we multiply the numerator and the denominator by the opposite sign of what's in the denominator. So the opposite of 1 minus 2i is 1 plus 2i. Then I'm going to put everything in parentheses so I can use the distributive property to multiply like we did in our previous example. So 7 times 1 is 7. 7 times 2i is 14i. 4i times 1 is 4i. And 4i times 2i is 8i squared. In the denominator, when we multiplied with radicals, we could use the shortcut method of multiplying the first terms, and the last terms, which we can do the same thing here with complex numbers because the middle terms are going to cancel. I am going to do the longer method to show you that they cancel, but you are more than welcome to do the shortcut method on any of our assignments. So when we distribute, we do 1 times 1, which is 1. 1 times 2i, which is 2i. Negative 2i times 1, which is negative 2i. And then negative 2i times 2i, which is negative 4i squared. Before we combine any like terms, we want to simplify our I squareds. So the 8i squared becomes 8 times negative 1, and negative 4i squared becomes negative 4 times negative 1. So our numerator is 17 plus 4i, 7 plus 14i plus 4i minus 8. And in our denominator, we see that the plus 2i and the minus 2i are going to cancel, and we're left with 1, and then negative 4 times negative 1 becomes positive 4. Then we can combine our like terms in our numerator. So 7 minus 8 is negative 1, and then 14i plus 4i gives us 18i, and then in our denominator, 1 plus 4 is 5. So in the notes and on multiple choice questions, what we're going to want to do is break this up into our complex number form, which is a plus bi. Because when we do this, sometimes our fractions are going to be able to simplify. In this case, it doesn't, but it could on future problems. So you are allowed on short answer problems to either leave it as a simplified fraction, as one fraction, or you can break it up into 2 fractions. So when I break it up, we do negative 1 over 5, and then plus, we can either write it as 18i over 5 or 18 over 5 and then the I next to it. Either one is acceptable. Let me know if you have any questions over section 1.